Hello students, welcome to my YouTube channel. Today we are going to solve the next questions from Keith Williams' VOR chapter, and the questions will be from question number 61 to question number 70. I have solved the previous questions and uploaded those videos on my channel in the playlist of Keith Williams Radio Navigation. So have a look at that and solve those questions as well. So let's begin with today's question number 1, which will be question 61. So it says you are on a compass heading of 090 on the radial 255. You set the course 190 on your OBS. What will the CDI bar show or the deviation bar show? Okay, so let's write what we have. We have a heading of 090 degree and we are on radial 255. So let's draw a VOR. Radial 255. So this is your radial 255. Okay, and you have set a course of 190 degree on your OBS. So 190 will be somewhat here, radial 190. The compass heading of your aircraft is 090. Compass heading of your aircraft is 090. Now in case of VOR OBS sums, the heading of aircraft will be irrelevant. In case of solving sums involving horizontal situation indicator, the heading of aircraft will be useful in determining whether aircraft is going inbound or outbound. But in case of OBS questions, you can ignore the aircraft heading. Okay. So now in this case, the heading of aircraft is 090. But irrespective of that, the OBS selector, the CDI needle in the OBS selector will show left or right deviation depending on the setting that you have put in it. So let's take two conditions. Now, when we are on radial 255, we will get a from indication if we put 255 in the OBS selector, and if aircraft is on the center line of that radial like here, the CDI needle will remain in the center. The CDI needle will remain in the center. Okay. Now, changing this OBS selector from 255 to 190. Changing this selector from 255 to 190 will continue to have or will continue to show from indication because 255 is a radial which takes you away from the VOR station. Similarly, radial 190 is a radial which will take you away from the station. So now when you're going or traveling away from the station outbound, this becomes your, this side becomes your left hand side, this side becomes your right hand side. Same goes with radial 190, this becomes your left, this becomes your right. Now when you are on radial 255 and you have set 190 in the OBS selector, the CDI indication, the CDI needle will move in that direction. That means what is the job of the CDI? The CDI tells you, the CDI gives you the solution. Okay, it gives you the solution. If the OBS setting does not match with the position of aircraft, CDI needle moves the CDI needle moves so as to enable pilot to turn his aircraft in the direction the direction where the course selected in the OBS. Okay, so the if the OBS setting doesn't match with the position of aircraft, the CDI needle will move in that direction in which the OBS course, the course that you have set in the OBS lies. Okay, so the pilot to turn his aircraft in the direction where the course selected in the OBS lies. Okay, so now for this example or for this question, you are on radial 255. Radial 190 is to the left hand side of radial 255 going outbound. So that means the CDI needle will move to the left hand side because currently aircraft is on radial 255, and to go on to radial 190, aircraft will have to turn left hand side. Okay, and then intercept that radial 190 and then fly outbound on radial 190. Now in this case the heading of aircraft is 090. Okay, but that heading is irrelevant to this question of VOR based OBS questions. Okay, VOR based OBS questions only take into consideration the course that you have set in the OBS. So if the course that you have set in the OBS is one of outbound radial, so all your left right indications will be with respect to that radial. Okay, your heading might be anything that is not relevant to the OBS working. All the indications that you will get is with respect to your current position, the current radial you are situated on, and with respect to that radial, where is the course that you have selected in the OBS lies, whether it lies to its left hand side or to its right hand side. Accordingly, you will get the CDI deviation movement. So in this case, the CDI needle must move to the left hand side, to the left hand side. Okay, telling the pilot to turn his aircraft to left and intercept radial 190 and then fly outbound on radial 190. So the correct answer will be uh, full scale deflection right. That is wrong. Full scale deflection right is wrong. Full scale deflection left with to indication. Full scale deflection left with a from indication. So the correct answer will be delta. Full scale deflection left with a from indication. Okay, because we have put the course 190, which is an outbound course, and we are also on radial 255. So the radials or the settings that we have, the settings that we have put in the OBS are for outbound tracks. Okay, in case of inbound tracks we will have to put a setting or a course which is any direction which is to this side of VOR, to the opposite side of VOR. Okay, in that case we would have gotten two indication, but when you are on this side of the VOR we will get from indication because the aircraft is on this side of VOR. To get a two indication we will have to go towards the VOR like this, and to and for that we will have to put courses which are on that side of the VOR. Okay, next question: how does the VOR DME in an area navigation system select the DME station to be used for positioning? So your area navigation system uses a combination of VOR DME, DME DME, like that. Okay, so in case of VOR DME combination, how does the system automatically select the DME station for our service? So is it that the pilot tunes the closest VOR DME stations within range of the panel? Is it VOR DME area nav system has its own nav tuner and the system itself tunes to the DME station closest to aircraft? The VOR DME nav system has its own nav tuner and the system itself tunes to the DME stations providing the most accurate position. The VOR DME nav system uses whatever stations are tuned on aircraft's normal VHF selector. So here the correct option will be option number C. Okay. So the VOR DME area navigation system will select that DME station which gives the most accurate, which gives the accurate position. Okay. So providing the most accurate position. Okay. So remember this question. And the answer for this is option number Charlie. Because the area navigation system, any navigation system should give us as the most accurate position or the information. Okay, for precision, in flying, for approaches, etc., etc. So that's why we need a station which is the best among all. So let's go to question 63. In order to measure the radial from a VOR, the aircraft VOR receiver does what? So radial from a VOR. So here, just a quick introduction. Your VOR station on the ground transmits two signals. The number one signal is your reference signal, and the second variable signal is your amplitude modulated signal. So reference signal is frequency modulated. It is frequency modulated, and variable signal which rotates around the VOR is your amplitude modulated. Okay, the phase difference between your reference signal and your variable signal, or in this case the phase difference or the angular separation between them is 90 degrees. We can call it phase difference of 90 degrees. That means these two waves, reference wave and variable waves, are separated from each other. Okay, they are not aligned with each other, they are separated, and therefore the phase difference between them is, the angular difference or separation between them is equal to 90 degrees. And that equals, and that 90 degree becomes a radial 0, 9 or 0. So when the phase difference is 0, 9 or 0 and variable signal is somewhere over here, okay, in that direction we will have a radial 0, 9 or 0. So this way, aircraft receiver measures the phase difference between reference wave and variable wave, and which is nothing but your radial of aircraft. So for example, let's say our aircraft is here. Now when this variable signal rotates around the VOR, at some point of time it will make a 270-degree turn and and pass the aircraft and pass this aircraft. When it passes this aircraft, the VOR receiver in this aircraft will measure the phase difference. Phase difference between this wave, that is your reference wave, reference signal, and this variable signal. Okay, and the angle will be equal to how much? This will be equal to 270 degree. Okay, so the VOR receiver measures this phase difference and interprets this information as aircraft being on radial 270. So this is how the system works, VOR system works. So the first option is measures the phase difference between the reference phase and variable phase, measures the time difference between sending interrogation signal and the reception signal. So this is wrong. Okay, so this is about radar. Okay, uses the pulse technique to determine the radial, again wrong. Measures time difference between reception of the two signals transmitted from the ground station. So this is also wrong. So this all three options are related to radar. So the correct option is option number A, like I explained now. Question 64. Apart from radials and distances from VOR DME stations, so VOR tells us about a position, the position on what radial we are situated on. DME distances stations give us the information about our slant distances, slant range. So apart from these two pieces of information, what information is required by the VOR DME area nav computer in order to calculate the wind? Okay, in order to calculate wind velocity, what other information is required apart from the position of aircraft and distance? So the correct option here will be option delta. It requires a heading of aircraft from which it derives from aircraft compass and true airspeed which it gets from air data computer. Okay, so to determine the wind velocity, there are four factors required: the position, the distance, true airspeed, and aircraft heading. So remember these four things for any of your ATPL, any Viva exam that you're going to take, be it ATPL, SPL, your airline exam. Okay, next. Question 65. Aircraft is on a heading of 180 magnetic. on a bearing of 270 from a VOR. So magnetic bearing from a VOR means you are on radial 270, also known as QDR 270. If QDR is 270, QDM will be equal to 090. The bearing you should select on the OBS to centralize the CDI needle with a 2 indication should be what? Very simple. So here is your VOR station. This is radial 270. This is radial 090. This is the northerly datum. Okay. Now when your aircraft is on radial 270, there are two possible directions your aircraft can fly. It can either fly away from it can fly either away from the station or towards the station. When it flies away from the station, the OBS setting should be 270 with a from indication, and if aircraft is right on the center of the radial, the CDI indication remains in the center. If aircraft flies inbound towards the VOR station, the OBS selector should have an input or setting of 090 with a 2 indication, and provided aircraft is established on the center line of the radial, the CDI needle will remain in the center. Okay, so going outbound on radial 270, you put 270. When going inbound towards the VOR, when going inbound on radial 270, the correct procedure is to put 090 so as to get 2 indication. Now when your aircraft overflies this VOR, the 2 from indication and the CDI needle will start flickering, and when it passes the VOR station and goes on the other side of the VOR station on radial 090, this 2 indication will become a from indication, and if you are correctly established on the center line of this radial going outbound, the CDI needle will also remain in the center. Okay, so this is the correct procedure, the normal procedure. Okay, we call normal sensing. So this is the normal procedure. So the correct setting will be, the question has asked us what will you select in the OBS in order to get a 2 indication. So you will select 090. Okay, so 090 degrees. Since you are on radial 270, the correct procedure will be to select 090. Question 66. Aircraft is at flight level 100, which is 10,000 feet. VOR is at 100 feet above mean sea level. What will be the maximum range? Use the formula. Maximum range is 1.25 H1 plus H2. 1.25 square root of 10,000 plus square root of 100. 1.25 square root of 10,000 is 100 plus 10. So 1.25 into 110, 137.5. The correct answer will be delta 137 nautical miles. Very simple formula based question. Question 67. Aircraft is at 6,400 feet and VOR is at 100 feet. What should be the range? So range should be 1.25. Same formula, square root of 6,400 plus square root of 100. So 1.25 square root of 6,400 equals to 80. Square root of 100 is 10. So 1.25 into 90 is 112.5. So correct answer will be option A, 113 nautical miles. Simple. Question 68. You have set an OBS, the OBS setting 048, and it shows 2 indication. The VOR deviation is showing full right deflection. Approximately what radial are you on? So let's draw a VOR station. So with 048 in your OBS, you get a 2 indication. So what is the reciprocal of 048? It is 228. So this is your radial 228. This is your radial 048. So pilot has put 048 in his OBS selector with a 2 indication. That means he is following radial 228 inbound. Okay, he is following radial 228 inbound. Okay, that's why he has put in his OBS selector, 048, obtained 2 indication. Okay, so and the CDI needle should remain in the center provided aircraft is in the center. But in the question it stated the bar has moved full right. The CDI needle has moved to the right hand side. So instead of being in the center, the CDI needle has moved to the right hand side. CDI needle has moved to the right hand side. Now the CDI needle gives us the solution, a solution to a problem. Okay, if it tells us to go right hand side, that means aircraft has deflected or deviated to the left hand side, to the left of the selected course. Okay, if the CDI needle moves to the left hand side, that means aircraft has deviated right side of the selected course in the OBS. So in this case, your aircraft should have been correctly established on radial 228 inbound. But the CDI needle has moved right hand side. That means aircraft has moved somewhere to the left hand side, going inbound. That means aircraft, aircraft has deflected somewhere to the left hand side. Okay, somewhere to the left hand side. Now going inbound, this becomes your left hand side and this becomes your right hand side. Okay, so the perspective is with respect to going inbound. Okay, so your aircraft is not on the center line, it is somewhere to the left of it, going inbound to the left hand side, and therefore the CDI needle has gone to the right hand side, telling aircraft to start turning right hand side so as to come back on this radial 228, so as to go inbound correctly. Okay, so what so this is, there will be a radial passing through this position also, like here, and this radial will be definitely more than radial 228. So it can be radial 229 or 230, 231, whatever. So what is the value of that radial? Now here it's given that full right deflection. Now has your CDI needle has one dot of a value 2 degrees, and full deflection means 5 dots, which is equal to 5 to the 10 degree. Okay, so full right deflection means aircraft has deviated 10 degree to the right hand side, 10 degree to the left hand side. So in this case, your aircraft has deviated to the left hand side, full left hand side. So full value is how much? 10 degree. So 228 plus 10 will be equal to 238. So that means aircraft is currently on radial 238 inbound. Okay, and the course selected in the OBS is not 238, but it is 048, which is reciprocal of 228, right? So in order to go to 048, to transition from radial 228 to 048, you must be established on radial 228 first and then fly inbound. If you follow radial 238 instead of 228 inbound, you won't go to radial 048. You will be transitioning from radial 238 towards the reciprocal of radial 238, which is nothing but 058. So instead of going on to 048 like this, your aircraft will fly here. It will come somewhere here. Okay, so that is not that's not what we want. Okay, we want to fly on radial 228 inbound. Okay, and that's why we have put a course of 048 with a 2 indication. Okay, two indications. So the correct answer is aircraft is on radial 238. Okay, and this is how we find it out. Let's go to question number 69. Aircraft is on a heading of 180 magnetic on a bearing of 270 from a VOR. Magnetic bearing from a VOR means aircraft is on radial 270 or QDR 270. So if QDR is 270, QDM is 090. The bearing that you should select on the OBS to centralize the VOR bar should be what? Now, if aircraft is on radial 270 from a VOR, so in the OBS setting, you should also put a course of 270. Okay, so if aircraft is on radial 270 and you put 270 in the OBS as well, the CDI needle in the OBS will remain in the center. So the correct option is 270. So yeah, now there are two possible answers actually, 270 and 090. Both will be correct. Okay, so uh, since aircraft is on 270 radial, with 270 in the OBS, you will get a from indication. With 090, you will get a to indication. Okay, so it talks about bearing. You should select. So bearing should be 270. In place of bearing, had they used the word course, the course to be selected, you would have selected option Charlie 090. Because in case of UR sums, radial or bearing is the word often used for tracks going outbound. When you are flying on a particular radial inbound towards the VOR, we use the word course, the course to be selected. So over here 270 should be the safe answer. Question 70. Aircraft is on a heading of 160. Aircraft is on radial 240 from a VOR, and in the HSI the code selected is 250. So simple. In HSI we do not have reverse sensing like in OBS. So all we have is normal sensing, and in whichever direction the needle moves, turn in that direction. So here we have two radials, radial 240 and radial 250. Okay, and your aircraft heading is 160, somewhere in that direction. With a heading of 160, you are still flying outbound. Okay, with a heading of 160, you are still flying outbound. So aircraft is on radial 240. Okay, 160 heading and radial 250 is selected. Okay, so what will you do? An aircraft is flying outbound. How you determine that? Currently you are on radial 240. So 240 minus 90 is what? 150. That means 240 plus 90 is 330. So in the sector between 150 and 330 clockwise, everything is outbound. If you are somewhere in this sector between 150 and 330 radian, in this sector on this side of the VOR, you are flying outbound. You are in the outbound sector. If you are on that side of the VOR between these two radials, you are going toward inbound towards the VOR. Okay. So if you select any radial or any course in the HSI or VOR OBS, which falls between these two, between 150 and 330, starting from 150 clockwise, you will get a from indication. If you put any course or direction in the OBS, which lies on that side of the VOR, which is between 330 and 150, starting from 330, ending at 150, you will get a 2 indication. So this is how you come to know. So in this case, aircraft has a heading of 160, which is more than 150, more than 150. So it is considered to be flying outbound from VOR. Not perfectly outbound, but still this sector is the outbound sector. Now we know that aircraft is flying outbound. So in your OBS correction, in your HSI, you will first have your magnetic heading shown on the top of the instrument. So there will be magnetic heading of 160 on the top. Then there will be a course needle. Now the course needle is 250. Okay, so pilot has selected 250. So the needle will point towards 250. We all know in the center of the HSI there is an aeroplane. There is an aeroplane which will be pointing towards the magnetic heading. Course selected is 250, and on either side of the course there will be a deviation needle, and that it will move left or right depending on the course selected. Then there will be two from indication, but unlike OBS in which we have the first two letters on the display, on the instrument display, 2 TO from FR. In case of HSI, we do not have those alphabets in front of us. We will have a small triangle. Now, if that triangle is ahead of this aircraft, somewhere here, so it means two indication. Okay, the triangle ahead of aircraft means two indication. If the triangle is behind aircraft symbol, so that means from indication. Now in this case, I told you we are in the outbound sector. With an outbound sector, you are flying away from the VOR. So the indication will be from indication, and therefore the triangle will be behind aircraft symbol, which means from. But this from won't be written on the instrument. You have to look at the triangle, whether it is ahead of aircraft or behind aircraft. If it's behind aircraft, that means you're tracking away from the VOR. And the next point is the location of the deviation needle. Now 250 is to the left of, is to the right of 240, and therefore most probably you will get a right hand turn direction from the current aircraft heading. So the needle will be over here on the second dot. In HSI, we have two dots on either side where one dot equals to 5 degree. So 5 twos are 10. So two dots, difference between them is 10 degree. So I have put the deviation needle on the second dot where the value is 10 degree. Okay. So the correct answer will be behind the airplane symbol with from indication. So correct option will be option A. Okay. The triangle behind aircraft symbol, which means from indication. So this is how you do the sum of HSI. Very simple. And I have also done many HSI questions from Keith Williams chapter in the previous video lectures. So for more practice, watch those videos, practice those HSI questions so that you may be confident in them. With this question, I will stop here. We will do the next questions in the next video lecture. So thank you for your time. I hope you have understood how to answer these 10 questions. If you have any doubts or questions, you can ask me in the comment box of this video. I'll definitely resolve them. Subscribe to this channel if you haven't yet, and do share this video with all your friends.